Good morning, students. As today 15 September 2022, it's a historic and emotional too for me. This is your science friend, Scientific Srinivas. See, my godfather, Shri Devadas, has developed this model, which was this won the national award too. Rotating magnetic field. See, here, three phases, the way they supply currents to three-phase loads without neutral, how the phasor diagram closes the circuit. This is the most complex to understand during my childhood time and even during my engineering time too. But later, one day when I went to Shri Devadas sir's home, and when I asked this question, how the circuit closes in three phase, then he said, okay, come to one demonstration which I'm going to do at IIT Ramaya's place. So on that day, he took me there and he demonstrated this. So see how beautifully he developed a working model to make us understand at what time which phase leads and supplies the current. So now I'm going to ask my assistant to push so that you can understand at what time. So now at 0 degree, you see, now you can see who is the one supplying the current. Okay, and again at 90 degrees, if you see that, see, at 90 degrees, exactly R phase at 90 degrees, you see, to make us understand exactly R phase is peaked. So R phase is supplying the maximum current. And similar to that, see, at every single time, at every point of time, at exactly 180 degrees, okay, now the Y phase is the peak, the maximum current supplied by the Y phase. You can see here in this drawing as well, there the Godfather's creation. And in similar to that, okay, now I'll go to 270 degrees. At 270 degrees, you can understand, and in similar to that, now at this degree, you can see the blue phase, okay, this maximum. So how beautifully Godfather made this device, a demonstration kit, to make us understand all the three phases at any point of time, which phase supplies current and which phase acts as a return path, and see how beautifully he demonstrated. So because of this demonstration, so in 1995 I understood all about three phases and the circuits and the loads working on three-phase powers. So definitely on this National Engineers Day in India, so I'm thanks to my godfather for creating such demonstrative models, working models during mid-80s and early 90s. So this model was demonstrated in many engineering colleges all across the nation and also in abroad. I thank Mr. Pavan for sending me my godfather's legacy. So thank you all on this Engineers Day. I hope you all understand such complex problems with simple demonstrations. So let's excel in engineering concepts raised from science, the basic science, Michael Faraday's, and then my godfather, Shri H. Devadas. So let's all do engineering excellent and then build India as a productive India. Thank you all.
In a coil like this, and in this space, we must get rotating magnetic field. How we get it? To just understand, analyze. This was done by me in 1962. 1970, government was very happy to give me a national award on this set of equipment. But due to the shortage of time, I'll just brush up and give just a glance of the ideas. This type of current, three phases, phase R, phase Y, phase B, is applied on a stator coil like this, like a stator. It has got slots in this. So the coils coming in this slot belongs to one phase, coils in this belong to the other phase, coils in this belong to the third phase. It's called a symmetrically distributed winding. When the currents of this, the three currents of this RYB is applied on this, the current flowing in this stator winding are displaced both in time and space. Because you see, B is here, Y is here, the current is also displaced. Because of the space and time, what happens is, we get in this position, if you just take the instantaneous values and just see, like a slide rule we can adjust it. It's a good and very interesting study. For study purpose for individual student it has been made, as it takes longer time. I tell the resultant of this flux makes it we feel that there is something like that. Although there is a North Pole here and South Pole here, by the application of all these three waves here, due to these three windings. As we go on increasing at 90 degrees, this will also change to 90 degrees. To 180 degrees, this is also 180 degrees. At 360 degrees. Yes? Yes, sir. I'll do it. It's a very good suggestion. This will be okay, sir? Okay, I'll come there. Thank you for the session. It has the synchronous speed, maximum flux that is available. All these things can be studied in this very, very easily, comfortably, and it is a very good academic tool. That's what people have played and enjoyed with this, they say. Now, whether we can really see the effects of the rotating field, I'll come to that. That will be interesting to all the people. This is the stator winding of the motor. We call this a stator because it is stationary. It is not moving. And it is just tied here. Like the motor is also by foundation bolts to tight. The stator is stationary. Now, our great friend, the honor is put in this stand. I just put it and through a regulated voltage, I just give voltage to it. This is showing a directional effect, and if I give a little push to it, you will see an indication that there is something which is rotating, which is able to rotate. There is a bit I put steel ball. What I do is, when steel ball would rotate, the pins would rotate, when I put a ring which is free to all of this, let us see. This ring is rotating, but is making more noise than what's right. Like a naughty student who does a lot of copying and studying, this is why, because apparently this looks like a very free movement to us. There is a gap here, axial gap, and longitudinal gap, and they are not equal, it is not concentric. We will remove this mechanical error and give a flywheel which is fixed on a very smooth moving ball bearing. This is much faster, much smoother, and we go like a very good student who does a very silent and beautiful study. You also can see by what is the effect of the air around it. If you minimize it, what happens? Where exactly it is more forceful. To see that, we'll put the rotor, this is the flow motor rotor, is an indicator which is showing there is a rotating magnetic field. Here I can stop it, reverse the direction of it, goes in the other way. Now I can gradually bring it down. It has started. With the increase of the air, the path of reluctance or the opposition for the magnetic flow is increasing, and at a particular point it gets stopped. With all this experience, whatever you have seen now, is it possible to make a small motor? We try to make a motor. Ladies and gentlemen, एक arrow निकाल के देना. My real rotor, because lot of copper conductors like this, and they are shorted at the end, called a squirrel cage rotor. This, the entire surface of this can, I call it as the conductor, longitudinal conductor, and the top and the bottom, the lid and the bottom, I call it as the short circuiting ring. So technically there must be some meaning in this. Let us try to verify. I think if not to appreciate me, to appreciate the Pond's powder, why don't you please clap? If there is a representative here, I think I can take some royalty from him. Now, this little Pond's powder is exhibiting the technical quality of a motor that by having the rotating field around it, there is no electrical connection between the stator, that is the stationary member, and the rotating member. Absolutely, it is running and it can attain a very, very high speed. But it's not so. It has got not horsepower, not cat power, but not even chua power. It has got some cockroach power. Now, when it is running, I can just stop it, reverse the direction of rotation by just interchanging any two leads. You can also find out what happens during single phasing, what is crawling, what are the harmonics, what are the distortion. I'll also put some load also this way. Now, because of the concentration of current, the induced current is more, so the torque developed by this motor or the driving force or the horsepower developed by this. So gradually we are trying to improve the performance of the motor by avoiding all these little mechanical and electrical errors. Please watch. One of you please note the time, how much time it takes to stop. Who will do it? Please note the time. 1, 2, 3. I have switched off. Please watch the time taken by this rotor to stop. Now, if I got a lathe machine, it has got a big flywheel. I put the job, switched on, turning is going on. I have to stop it. Can I afford to wait for such a long time? 56. 1 minute. Now it has taken only 6 seconds. So like this, by using rotating magnetic field, is called as counter switching or counter switching of the field, like that. Friends, any motor is basically a transformer. Any motor is basically a transformer. Particularly industrial motor is called as rotating transformer. It has got the qualities of a transformer. What is the quality? Primary winding, secondary winding. Some of these state rotors may be short-circuited rotors. Like this squirrel cage motor, they are all short-circuited, permanently short-circuited. Some are short-circuited at our will, called as wound rotors. This is short-circuited whenever you want, to the extent you want. Thereby you can control the speed also. There are got used as slip ring motors used in crane with good higher torque and all those things. No, basically therefore, each motor is nothing but a transformer. I want to just prove by this small gadget. There are two sets of coils which can be rotated on the shaft. These coils are connected to two bulbs. So as a transformer, what should happen to the bulbs? They should glow. If I hold it, they should glow. If I allow it, what happens? Mechanical power will come, the electric power consumption will go down. Let us watch it. If only entertainment is the purpose. So, shall I proceed to the entertainment?
Yes.
Are you all ready? So, please hear me up. One thing, if you are really entertained,